Let's start. So what we discussed yesterday, we have discussed few things, and I've asked few things in vCenter on the features and the services and components and the maximums. What is the maximum number of hosts that you can add into the cluster, and maximum number of VMs on top of any ES6 host. These things we discussed in the last session. And today we'll discuss about VMware networking part. So before we start with the networking, I would like to understand few basic terms. I would like to understand few basic terms. So let me start with what is IP address? Anyone? Basic. Sorry. IP addressing. So what kind of IP addressing you people are using in your current organization or at home or at offices or outside? And what is your understanding on this?
IPv4 using in office.
IP
V4.
V4. What it is? What is IP V6? What is the difference between these two? First of all, IP config. I got a 2, right? IPv4 address and V6 address. So what is the difference between these two? Which one you people are using it more? Hello.
If we want more IP,
Hello.
so we
Yeah, you have to be more interactive, man. It's just not like you're
Hello.
simply
Hello.
listening, you're
Hello.
simply watching the YouTube videos. Yeah, I'm able to hear you. I want you to be more
Actually, it
interactive.
is stuck on unmuting. Okay. IPv4, I think it is a short address. It's like 32-bit address. And
Yes.
IPv6 is 128-bit address. So that is a
So
difference between both of them.
the basic difference is
And
yes, 32 bit.
currently, I think currently we have
28.
enough of IPv4, so that's why we are not going to IPv6. So most of
Still,
the places we use IPv4.
yeah, still we are using the IPv4 because we have adequate IPs to manage the day to day. Okay, now basically you have two types of IPv4 or two types of IP addresses. Public IP address. Another one is
Private IP address.
private IP addresses. Okay, what is the difference between these two? Hmm? What is difference between these two?
Public and private. Public we use to connect WAN to WAN, and
WAN to WAN.
private mostly we use for LAN, WAN to WAN, yeah. And private IP addresses we usually use for internal purposes, like inside the LAN.
Okay. What is the difference between routable and non-routable API?
Uh,
So routable IP addresses are the public IP addresses. Non-routable IP addresses are private IP addresses. Now, how you will identify whether it is a public IP or it's a private IP? How you will come to know? I have this IP address. Can you tell me whether it is a public or private?
Yeah,
Hmm?
It is
it,
private.
yeah, we
So
can
private.
define it with the help of classes.
My simple question is, I have this IP address. Can you tell me whether it is a private or a public?
Yeah,
Hmm?
yeah, very in the IP
Sorry?
192, 192.168.
Hmm.
Which IP address is 192.168? One. This is the private IP address.
Yes. Now how you will come to know?
I think it depends upon the ranges and the classes in which
Okay.
private and publics are defined.
Yeah, let's do one thing. So let me open up this. So basically, you have all the IP addresses are divided into different classes. Class A, class B, class C, right? I'm not interested in class D and E because they are not IP address classes. We'll see. Class D and E, I'm not interested because these are not used for or not released for public usage. So far the global usage is in between A, B and C. Okay, let me see. So class A basically starts with 120, right?
Yeah.
Not 127. I believe 126 only because 127 is local host. Let me go back. See, 126 only, not 127. 128.0.0 to 191, right? And class C starts with 2. This is the range. So if you ever see any IP address within this range, you can call it as class C. Now tell me, what is my IP address? It belongs to class C. Okay. So these IP addresses further divided into public and private.
Private.
Okay. So how we will define these two? In class A, if you ever see IP address starts with this, right? This is private IP address. Then what is public IP address? And 2 126 dot public range. Understood?
Yeah.
Hmm?
Yeah.
Now can you give me some examples which are running on be on mute. If you are getting a noise, please be on mute. Whenever you want to talk, you can unmute and talk. Ping 176. See, right? What is this? Class A or not? Class A public IP or not?
Yes, class A public IP.
Right? So means this is routable IP means you can access the IP over the internet. Over the internet, you can route the data, right? See, it's pinging. Okay, you can also ping the same IP if you want, but this is my IP. You cannot ping this IP. I can ping it because it is my local host. If you try to ping this, you will not be able to ping because this is non-routable and my local private IP. You will not be able to reach this host from your laptop or desktop. Okay, so that's the difference between routable and non-routable. Clear on class A? When it comes to class B, again it has both private and public. So in private range 172.16.0.0 to 172.31.255 and 255 private range, these are non-routable IPs. And what is the public IP? 128.0.0.0 to 172.15. And 172.32.0.0 to example, you have it here, right? Agree? And when it comes to class C, 192.168.0.0 to 192.168.255.255 range, 192.0.0.0 to 192.167.255.255 and 192.169.0.0 to public range. And what is an example? Ping C.
Yes.
This comes under, right? And 149. 149 means class B, right? 216. Okay, getting my point? So you take anything, it must be associated with one public IP. Hmm? Clear?
Yeah.
And then where you will use these private ranges? So if you see large enterprises, they'll use class A. Medium and small
Class B.
enterprises, they'll use class B. And home and small enterprises, I can say. use class C. Now my IP address is this 192.168.1.20. 192.168.1.20 within the range, right? Even if you have a Wi-Fi router at your home, that will have 192.168 range. Or you have a mobile phone, you want to share your Wi-Fi with someone. If you enable Wi-Fi tethering hotspot, it will also generate some DHCP range 192.168.0.0 to 192.168.255.255. Within this range, it will run one DHCP service so that others can connect to your Wi-Fi and access the internet over private IP called class C 192.168 range. Clear? Or any questions on this? Everyone, hello.
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 Any questions?
No.
Yes or no?
Sir.
Okay, cool. So let's go ahead. Now let me understand few more things. I've already explained you my home lab setup. So still I need to reiterate once again just to demonstrate the networking. So okay, ESXi host 192.168.1.151, right? And Cisco switch 192.168.1.100. TP-Link Wi-Fi router 192.168.1.1, right? So I picked one cable and connected here. I picked one more cable and connected here. And I picked one more cable connected here. And internet cable gone to internet. So how many IPs I have in the picture?
4.
4.
4. Okay, but there is one more IP called
Public IP.
public IP. What is that? What is this public IP? Let me check. This is my public IP. Okay, this is my public IP. Now from my laptop, can I access the internet? Ping google.com, right?
Yes.
I'm getting output. One second. One second. Okay, so I'm getting output. So I want to trace the path. Google.com. Now, first when I tried, first it went to my switch. From where? my laptop. From my laptop went to switch. From switch it went to TP-Link, right? From TP-Link it went to some output is this, right? This is my public IP, and then it went to some IP here, and again it went to 4 more destinations. Means, let me,
The
okay,
nearby DNS.
no, okay, so from here it went to somewhere else, and from somewhere else it went to somewhere else, and somewhere else it went to the destination. This is the destination. In between it can take n number of paths, doesn't matter, right? This is the trace route from my laptop to google.com. Now in this picture I want to understand where is the public IP, or where is the, sorry, where is the public IP and where is the private IP. Let me clearly draw some line. Clear?
Yes.
Understood? Now from my laptop, just a moment, just a moment. I'm sorry, yeah, from my laptop I want to ping, pinging. What is this? What is this 55? This is one of the virtual machine in my ESXi, and the purpose of this machine is,
VDS.
right? Now from my laptop I pinged this machine. Anyway, it is communicating like this. Agree? Now what is the difference between these two pings? If I ping google.com, it is going to internet. If I ping my private IP, it is going to reach here. So let me trace route. Trace RT 192.168.30.55. Again, first it will go to my switch, right? Then it went to 30.55. First it goes to my switch, then it went to 30.55. Clear?
Yes.
Now I'll ping this one. Sorry, I'll ping my base host. I'm sorry. Let me clear this off. I'll ping base host. Ping 192.168.1.151. It is also pinging. Let's do the trace route. 192.168.1.151. direct, you see, but data is traveling from this switch to it came to here, but it is skipping the switch, it is not showing the switch. But when I ping,
Yeah, why?
when I ping the machine, it is going to switch, and from switch it is moving data here. But when I ping the host, it is going to the switch, again it going to the host, still it is not showing up the switch. Any specific reason? You understand my query?
Yeah.
Trace route. Now, what is the difference between these two trace routes? Because source is same, destination is also one box, but your one in one trace route there is no switch, in another trace route there is a switch.
I
Understand?
think
Okay, let's understand few things. So here there is a concept called VLAN. So I have defined one VLAN. Okay, I can define the VLAN with my custom range. I can define the VLANs with my custom range. I have defined one VLAN 192.168.1.0/24. Understand carefully. If I give /24 like this, this means within this VLAN range 192.168.1.0 to 192.168.1.255. It's a complete boundary. That's it. It is one logical boundary, right? Within this boundary, you need to ignore 0 and 255. I'm not going to the CCNA class. Just remember 0 and 255 will be ignored. You cannot use them. Then how many you left with? You left with 254 IP addresses. 1 to 254. 0 and 255 are gone. 1 to 254. So you'll have a 254 IP addresses. So within this 254 range, one must act as a gateway. You must select one gateway. So I have selected gateway as 192.168.1.100. You can select anything. You can select 1.1, you can select 1.254, you can select anything. One must act as a gateway. Now I said I have selected my gateway as a 1.100. Now when you are sending a data from one source to destination, how that packet will construct? Source IP, destination IP, and acknowledgement bit. Right? Now I'm trying to ping from source 192.168.1.20 to destination is 192.168.1.151. You understand? This is source, this is destination in one request. Right? In the first request. Now this packet will be broadcasted across the 254 IP ranges. Hello?
hello.
Audible?
Yeah.
Now, what I'm saying, this packet will be broadcasted between 0.1.0 and 1.255. So, do you find a destination within the range?
Yeah, it is in the range.
It is within the boundary, within the broadcast boundary or not?
Yeah.
So,
It is in the
it will,
boundary.
yeah, it will directly accept the packet and send acknowledgement to source. You understand? Now, in this
Yeah.
scenario, gateway is not in the picture. You understood? Because
Yes.
source and
Got it.
destination are within the VLAN range or within the VLAN. In this case, gateway will not be in the picture. That is the reason when you trace route 151 from 1.20, you will not see gateway. Clear this point? And the second point is, let's take the same example. Source, destination, acknowledgement. Now, source is same 192, 168, 1.20. Now, destination is 192, 168, 30.55. Now, this packet will be broadcasted again between this range. Do you see that a destination is matching within the range? Hello?
Yes.
Not within the range.
Yeah, be proactive. Okay, let's speak up, man. I want interactive session. Within the range or not?
Not.
Then what will happen? This gateway will come into picture. It will pick the packet. It will pick the packet, and you might have n number of VLANs defined in such a way. You can define n number of VLANs, right? So there is another VLAN called VLAN 30. The range is 192.168.30.0/24, means 192.168.30.1, sorry, 30.0 to 192.168.30.255. This is the range. This is another VLAN, another boundary, right? So this gateway will pick the packet, and even this VLAN has boundary, right? What is the boundary? 30.1 to 30.254. Agree or not agree?
Yes, yes.
Okay. Now within this range, there must be one gateway here. Okay. Now I'll say this is 30.1 is my gateway here. For VLAN 30.1 is gateway. I said you can select any IP as a gateway. It not just 100, 1.1, 1.2, 1.3. You can select anything as a gateway within that boundary. Now I said I have selected this as a gateway. Now what will happen? This gateway will pick the packet and route it to this gateway. This gateway receive the packet and it will again broadcast in the range. Now you look at this range and see destination is matching or not.
Yes.
Matching. So somewhere here there is a IP destination called 30.55. This will accept the packet and send acknowledgement back to gateway. This gateway will send acknowledgement back to this gateway. This gateway will send acknowledgement back to 20. The server is somewhere here. You understand the second one, and you understand the first scenario. If the source and destination are within the VLAN, then gateway will not be in the picture. If the source and destination are in a different VLAN, then you will see gateway will come into picture. Okay, then what is VLAN? VLAN is your logical boundary. Why you need a VLAN? Let's understand very simple logic. I have 3-tier application. There is a database here and some Python application server and some PHP or Node.js web server, application server, database server. Web server, if someone is trying to access the website, it should accept www so on. So if someone is typed this IP or this URL, okay, it will reach this server. Now whatever the output or whatever the website you hosted here, it will display. Now there is a form inside the page. You fill that form. This form has some data. Website will now send it to application server. Application server will now save into the database. Agree? Logic. Now, do you need database server in accessible on the internet, or application server accessible on internet, or web server accessible on the internet? Which one you need over the internet? Web server you need on internet.
Web server.
Application server you don't require internet access, and DB server more secure, you don't require internet access. So what you can do, web server you can put on VLAN 1, application server you can put on VLAN 2, DB server you can put on VLAN 30, whatever. It is just your logical creation, right? So you can set some rules. All the servers in VLAN 1 can talk to internet or can accept the data from internet and can only send data to VLAN 2. Now on the VLAN 2 you can put some rules saying VLAN 2 is responsible to accept anything from VLAN 1 and it will not accept anything else. If the request came in from VLAN 1, it will accept. If the request came in from VLAN A, B, C, D, X, Y, Z, 200, 290, whatever the VLAN, it won't accept. Okay, and from VLAN 2, it can only send and receive data to VLAN 30 as well. Okay, these kind of rules I can set here. And the third one, VLAN 30 is more secure. If there is any data which is coming from VLAN 2, accept it. Otherwise, reject it. Very simple rule. If the source is VLAN 2, accept. If the source is something else, reject. Clear? So in order to provide your application with more secure and reliable, you have to create your VLANs. So where you will create a VLANs, let's go back and log into the switch. So this is my switch. Login. Now I'll say VLAN management. I'll go to, by default I have a VLAN ID. So my default VLAN is 1. Now VLAN settings, if you go to VLAN settings, you can create a VLAN. How to create a VLAN? Very simple. Just give VLAN ID 222, VLAN 222. Okay, apply, that's it. VLAN will be created. How many VLANs you can create in one switch? 4094. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 VLANs I have created. Similarly, see, 222 is already created. I'll simply select and delete it. Okay, so I can create 4000 plus VLANs here. That's fine. Okay, VLAN created. And how switch will you come to know for which VLAN what is the IP range? Now, what is class C IP range was? This is class C IP range, right? Now what I will do, let me do small calculation here. Subnet masking, little tricky, but remember in such a way. You don't need to be network expert. So by default, let's say 192.168.1.0/24 means how many IP addresses, boss? 254 IP addresses. /24 means 256. Remember 256 because /24 0 to 255. Now I have to create one more range 192.168.2.0/25. 128 divided by 2. If you increase 1 divided by 2 /26 64 again divided by 2 /27 32 again divided by 2 /28 16 /29 8 IP addresses you'll get /34 okay /31 2 IP addresses you'll get /32 only one IP address means /32 is last. Clear? Downside. Let's go to upside. /22 512 /21,024 /20 2048 /19 4096 /18 how much 8162 correct or no? So 8000 let's take /17 how much 16,000 oh, something wrong /23 22 21 20 19 18 18 means /18 means 16,000 IP addresses around 16,000 /17 means 32,000 IP addresses /16 means 65,000 IP addresses. Understood?
Yes.
Okay. If you are ever playing with these ranges. Now class C has the total range of class C is something. The total range of class C. Remember class C 192.168.0.0 to 192.168.255.255 equal to sorry 65,000. Okay, this is total range. This equal to 65,000 means the total class C itself /16. Okay, okay. Now I can create multiple VLANs here. VLAN 1, VLAN 1, 192.168.0.0/24 means 192.168.0.1 to 192.168.0.255. This is one range VLAN 1. Can I create VLAN 0? Just give VLAN 0. Okay, VLAN 1 I'll give in such a way 192.168.1.0/24 means 192.168.1.0 to or 1.1 to 0 anyway we're not going to use it, right? 192.168.1.254 VLAN 2 2.0/24 means 192.168 1 dot sorry 2.1 to 192.168 2.254 and so on 192.168.254.0/24 192.168.254.0 or 254.1 to 192.168.254.254. This is the last. So these are all these are /24. If you have a /16, out of /16, how many /24 subnets you can create? 0, 1, 2, 3, 4, 5, and so on. 254 VLANs means from class C you can create 254 VLANs. Example. Okay, now in my picture I created VLAN 1, 2, 3, 4, 10, 20, 30, 40, 50, 60, 100 like this. But when I map with the IP addresses, I can map any IP. VLAN 1 this range, VLAN 2 this range. I can map any IP, right? There is no limitation. It is just a logical mapping. So go to IP configuration. So I said for VLAN 1 this is the gateway. VLAN 2 this is the gateway. What is this gateway, boss? Just take the browser and put it on browser. Again just take this IP, put it on browser. You will get the same thing. You see, same switch 10.1. Okay, 20.1. Same thing you are getting for all the VLANs 192.168 100.1. I haven't defined it properly. 100.1 is not working. 70.1. Let's try because I haven't configured all of them properly. 70.1. It's working, right? So for all the VLANs, the gateway is same. You have only one device, only one device. In that one device, you defined everything here, right? Everything in one device. And this device will act as a gateway for each VLAN. Understood?
Yes.
Okay. Now, if you go back to the previous example, you see in first example, there is no gateway in the picture because within the rest they communicated, it's gone. And in the second example, source is different, destination is different. And I said this request is hand over to gateway and it hand over to another gateway. What is this another gateway? It is also configured on the same switch only, right?
Yes.
Understood? Let me go back to here. 10.1.100 is the gateway for VLAN 1. It is configured on this switch. And VLAN 30.1 is the gateway, which is also configured on the same switch only. Means both the gateways are resided, or in short, all the gateways are resided in one switch only. You got this point? All the gateways are in one switch. So when the request came in, gateway will pick. Gateway has 30 doors or 254 doors. Each door will act as a one gateway. So from one door you came in, from another door you came out. One door is 1.100, you came in, another door is 30.1, you came out and broadcast again on that range. Understood? or any confusion?
Basically, it's a feature of a switch, which is now we can call it as a modular switch, I guess. Because
I know.
if
I'm not,
we
see,
switches,
let me explain one thing. I'm not explaining anything in a technical language. I'm explaining in a very layman. You just have to understand how this is traveling. This is not the CCNA.
yeah,
I just want to make you aware that how it is functioning and in real time how it looks like. Right? Technically, there might be n number of names. Modular
yeah,
switch, managed switch, L2 switch, L3 switch, right? Hub, Spock. You have n number of names in real time. But I'm not going into that level. I'm just explaining in very layman language. This is how it is working. This is how I set up at my home. You understand this practically?
yeah.
Hmm? Now
Yes.
I gave you time yesterday and day before yesterday. I gave you all these questions. Now you tell me what you have learned yesterday and day before yesterday. Mali the
Regarding
class lo
this,
unna. Yeah, if you recollect, I gave you these questions day before yesterday, man.
yeah, yeah.
Right? So these are the these are the things I have explained today. I haven't started this, right? If
So
you look at, I
it's
haven't
gone through
started
the
any.
basic things.
I have explained only these things, and I gave you these questions day before yesterday,
Yeah,
right? If you are really bookish knowledge, if you really want a bookish knowledge, you should have do some googling. I gave you 2 days time. Now I explained in my way. If how I hope you understand what I am trying to explain in physical world. Now, if I move on to the virtual world, it is something different. This we need to understand again. Both are two different concepts. If you
yes,
are you fine with this? You have any questions on this?
yeah. No,
Okay, fine. So let me stop here. I'll give you one more day. So we'll discuss these things tomorrow. So you can do some googling on this, and then I'll explain tomorrow what it is. I hope you got
yes,
it.
yeah.
Okay, so let me stop here. We'll catch up tomorrow, same time, and we'll discuss virtualization part. I hope the physical part is clear. If you have any questions, you watch the video once again, or you do these technical terms in a Googling or watch some other videos in YouTube. You'll get some understanding on basic networking. Because without networking, VMware is nothing.
Yes,
Yes. If you simply log in, right click, create a VM, next, finish, select a VLAN, IP address, assignment, template, clone, done, and close the ticket. This is not going to be okay in this way.
yes,
Okay. So let me stop here. We'll catch up tomorrow and be prepared for next class. So do some Googling. We'll discuss the other networking aspects from tomorrow. It will take around 4 to 5 days, right? 4 5 continuous sessions on the networking. So you can spend some time and you can learn few things on your own. I'll show you some of these things, but I'll not be able to touch upon the pure technical words that you have to understand. If you are purely looking for index or a textbook answers, do some googling. This won't cover what exactly the technical term says, but this is only covers how it works. If something goes wrong, what you can do. There are two different ways. Okay, cracking interview, gaining knowledge, both are different. Clear?
yes.
Sunil, any questions?
No, sir.
Okay, watch this video after some time. I'll upload this and watch it. Then we'll discuss more networking tomorrow. Right? See you.
Okay. Okay. Thank you.
Thanks. Bye.